tricky question is that we have this tent peg with a weight, and it's best to just start with the force body diagram, the free body diagram. So we've got a tension here, and we have an angle here of theta, it's 40 degrees. We've also got a weight pushing down, and then let's talk about the normal force a moment here, and then we've got the force of friction, or we'll say force of static friction, off to the left. And the question is, how taut can this tension rope be? Now, I think the best way to look at this and think about this is to actually break the tension down into its two components. So this will be T cos theta, if you think about it, and then upward will be T sine theta. And the force of friction, so when it's going to start to move is when the force of static friction is equal to T cos theta. And you're trying to solve for T. So now we need to spend some time in trying to solve for the force of static friction. Well, we know force of friction, or force of static, is equal to mu static times the normal force. Now, what's the deal on the normal force, though? Now, normal force, we might be tempted to just say it's equal to the weight. But remember, we've also got this feature right here, T sine theta, which is lifting up on the weight right here. And so if you think about it, it's the normal force. The normal force is going to be the weight. Now think of this through, minus T sine theta. Now wait a second, what do you mean minus T sine theta? Now remember, if you have we do this in class, if I've got a chair or a stool and it's got its weight pushing down, but if I were to add a force upwards, a slight force, I'm not lifting it off the table, that will reduce the normal force, because conversely, if I push down on it, the ground has to push harder back up. So I lift it up, it's minus. So this is your normal force. So if we plug this all in right here, I can say the force of static friction, what does that equal to? It's mu times the normal force, which is mu, and they gave us mu, 0.6. 0.6 times the quantity, because this is the normal force, mg minus T sine theta. Now we know theta is 40 degrees. And that has to equal to T cos theta. So T cos theta. So this is our big equation right here. You know everything here except for T. You know M, that was 3. You know G is 9.8. And you know theta is 40. And so I would plug this into my solver, and it will give you T. There you go.